to be going over variation problems. And these are the three main rules for solving variation problems. Notice you're solving for y, and k is your constant, meaning k occurs in every single formula. So when two variables are mentioned and the phrase varies directly is used, you know you're multiplying. K times one of your variables equals y. Now, if we say varies jointly with x and y, it's still multiplication. It's just letting you know that you've got two variables multiplying together with your k, your constant. And then y varies inversely with x. Now, when the phrase inversely is used, it indicates division. So you've got k over x. Now remember, you have to solve for k before you solve for y. So we'll make some more sense of that once we get into a couple of the example problems. So this is one of the more easy problems that you're going to see because it just straight up gives you like variables as letters instead of like putting it into a word problem. So we're just going to set it up in your basic format. So let's look at the vocabulary. If y varies directly as x or with x and inversely with z, there we go. We know how to set it up. So y varies directly with x, so we know we're multiplying our constant times x. And inversely with z, we know we're dividing it all by z. So step one, we just set up our formula. Then the question is going to go on to give us the stuff we need to solve for k. And y equals 22 when x equals 4 and z equals 6. We use that information to find k, our constant. So we plug it into our formula, basic algebra, solve for k. We find that k is 33. We plug that back into our formula, and now our only missing pieces are our variables. And the problem is going to give you those variables, whether it's just a flat out problem like this or it's a word problem. So in this case, our variables, find y when x equals 10 and z equals 25. So we plug that in here, basic algebra, and you come to the conclusion that y equals 66 fifths, and you're done. Okay, so now we're going to do a word problem, like I was talking about in the last one. And this is a fairly simple word problem. So let's address our variables. So the cost of the pizza varies directly as with the square of its radius. Okay, that's what we need to know. So we know y varies directly with, obviously our constant is there, with x. In this case, y is our cost, constant stays the same, and x is the radius of the pizza, the square of the radius of the pizza. So our equation is cost equals constant times radius squared. So we're going to plug everything in and solve for k. If a pizza with a 6-inch radius costs $8, how much should a pizza with an 11-inch radius cost? Okay, so we plug everything in. 6 squared, 36, basic algebra, solve for k. K is 2/9. So then we're going to plug that in to our formula that'll find us our cost. We know cost equals 2/9 times the radius squared. So we plug everything in. We know in this case we have an 11-inch radius. Basic algebra, you find that the cost equals 242 ninths. Now, of course, you'll have to convert that into dollars, but that's basic math. As long as you know how to get through this process, you've got the gist of it. More challenging word problem. Obviously, we've got a lot more to deal with, and our equation is going to be a little bit more complicated. But we're going to follow the same system. The volume of the gas varies directly with the temperature and inversely with the pressure. So we know our volume varies directly with the temperature, and also, our constant is always there, and inversely, which is our division, with the pressure. So there we've got our formula. So then we're just going to plug in our variables from the question. And in this case, we've got a volume of 230 cubic centimeters, a temperature of 300 degrees Kelvin, and a pressure of 20 pounds per square centimeter. So we plug it all in, solve for k using our basic algebra, and we're done. So then we plug that back in to our original equation. We've got V equals 46T over 3P. And we'll go back to the question, find our variables. What is the volume when the temperature is 270 degrees Kelvin and the pressure is 30 pounds per square centimeter? Plug it in, solve it out, and you've got your volume, 138 cubic centimeters.